In this next example, we're going to decompose a vector. We have a vector v is equal to 2I minus 3j, and we have a vector w is equal to I minus j. What we want to do is decompose vector v into two vectors v1 and v2. The vector v1 is going to be parallel to the vector w, and the vector v2 is going to be orthogonal to the vector w. Here's how we proceed. First, what we need to do is find this vector v1. The vector v1 is going to be equal to the dot product of the vectors v and w divided by the magnitude of the vector w squared, and then times the vector w. Well, to find v dot w, remember you multiply the components on I, so I have 2 times 1, and then add that to the product of the components on j, so that's negative 3 times negative 1. And then I'm going to divide this by the magnitude of the vector w. The magnitude of the vector w is the square root of the sum of the squares of the components of the vector w, so that's going to be the square root of 1 squared plus negative 1 squared. And then I'll just go ahead and write the vector w, I minus j. So now let's work this all out. I have 2 times 1 is 2, and this is going to be plus 3, so that's 5. And the denominator is going to be the square root of 2. And then I have to square that result. I forgot to put the square up there, but that's okay. We can recover. So I square that result, and then I have times the vector w, I minus j. Well, square root of 2 squared is 2, so I have 5 halves, and then if you let me distribute that, I get 5 halves I minus 5 halves j. So there's the vector v1. This vector is parallel with this vector. You can clearly see that they're parallel because if you took vector w and multiplied it by 5 halves, you'd get vector v. So vector v is just 5 halves longer than vector w. Next, what we want to do is find the vector that is orthogonal to w. To find the vector that's orthogonal to w, all we do is we say that we have this vector v2, and it's going to be vector v minus vector 1. So vector v, recall, is 2i minus 3j, and then it's going to be minus the 5 halves I minus 5 halves j. So 2 minus 5 halves is negative 1/2 I, and then negative 3 minus a negative 5 halves is negative 3 plus 5 halves, which is going to be negative 1/2 j. So the vector v sub 2 is orthogonal to the vector w. You can verify that result by verifying that vector 2 dot vector w is in fact equal to 0. I'll leave that up to you.